Force and motion. We have learned that a force is necessary to change the speed as well as the direction of motion of an object. In the previous grade, we also studied the 3 laws of motion. Do you remember them? Come, let us revise the laws of motion quickly. Newton's first law of motion. An object continues to remain at rest or in a state of uniform motion along a straight line unless an external unbalanced force acts on it. Newton's second law of motion. The rate of change of momentum is proportional to the applied force, and the change of momentum occurs in the direction of the force. Newton's third law of motion. Every action force has an equal and opposite reaction force which acts simultaneously. After revising the laws of motion, let us now study about circular motion. Circular motion and centripetal force. Let us first perform an activity. Let us tie a stone to one end of a string. Now take the other end of the string in the hand and rotate the string so that the stone moves along a circle. On the stone, moving along a circular path, we are applying a force. As long as we are holding the string, we are pulling the stone towards us. That is, towards the center of the circle. If we release the string, the force applied by us on the stone stops acting, and at that instant, the stone flies off along a straight line, which is the tangent to the circle at the position of the stone. The stone goes along the tangent because that is the direction of the velocity of stone at that instant of time. We had performed a similar kind of activity in the previous grade. Do you remember that activity? In that activity, a 5 rupee coin was kept on a rotating circular disc. We observed that, as the disc moves with high speed, the coin placed at the edge of the disc is thrown off. When the coin is thrown off from the disc, it is in the direction of the tangent which is perpendicular to the radius of the disc. From the observation of both these activities, it is clear that a force acts on any object moving along a circle and it is directed towards the center of the circle. This force is called centripetal force. The word centripetal means center seeking. That is, the object tries to go towards the center of the circle because of this force. We know that the natural satellite of the Earth, the Moon, goes round it in a definite orbit. During this motion, the direction of the motion of the Moon constantly changes, and so its velocity constantly changes. A force is constantly exerted on the Moon to make it revolve in a specific orbit around the Earth. The Earth directs this force towards its center. If no such attractive force would have existed, then the Moon would have shown linear motion. Like the Moon, other planets in the solar system too revolve around the Sun in specific orbits. There exists such a force on these revolving planets as well. That is, the Sun must be attracting the planets, including the Earth, towards itself. Come, before we proceed to the next part, let us know about one scientist. Introduction to scientist. Johannes Kepler was a German astronomer and mathematician. In 1601, Kepler started working as a helper to the famous astronomer Tycho Brahe. After the sudden death of Brahe in 1601, Kepler was appointed as the royal mathematician in his place. He used the observations of the planetary motions made by Brahe to discover the laws of planetary motion. He wrote several books. Kepler's work was later used by Newton in postulating his law of gravitation. Come then, let us study the laws stated by Kepler.